choice. All right, Advent of Code 2023, day 6. Let's dig in. Day 6, wait for it. The ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here. Oh, that's right, the gardener was out of sand or something. But you don't see anything besides lots of water and the small island where the ferry has docked. As you try to figure out what to do next, you notice a poster on the wall near the ferry dock. Okay, we didn't see anything but lots of water in the ferry dock, and now we have a poster. Okay. Boat race is open to the public. Grand prize is on all expenses paid trip to Desert Island. I guess that's where the sand is. That must be where the sand comes from. Okay. Best of all, boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. The organizer explains that it's not really the traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. As part of signing up, you get a sheet of paper, your puzzle input, that lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. Okay. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats. Toy boats. That's hard to say. Each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but the time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and the boats don't move until the button is released. All right. For example, 7:15:30, distance 9:40, 200. This document describes 3 races. The first race lasts, milliseconds. Wow. Okay. First race lasts 7 milliseconds. The record distance in this race is 9 millimeters. I think just pushing the button down on the boat will move it more than 9 millimeters, but let's just keep rolling. The second race lasts 15 milliseconds. Record distance is 40 millimeters. Okay. Your toy boat has a starting speed of 0 millimeters per second. For each whole millisecond, he could have just used seconds and meters, right? For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per millisecond. So because the first race lasts 7 milliseconds, you only have a few options. Don't hold the button at all, so it won't go anywhere. Hold it for 1. If you hold it for 1, the boat will travel 1 millimeter per second for 6 millimeters because there's only 6 seconds left in the race. I understand. 2, which means you only have 5 milliseconds left, but you're going 2 milliseconds per millimeter, 2 millimeters per millisecond, sorry. So you can go 10 millimeters. 3 and 4 are 12. 5 is back down to 10. 6 is down to 6. And 7 get to go at all. Okay, so it's like this curve. I'm seeing a curve in my mind here. Since the current record for this race is 9, there are actually 4 different ways you could win. In the second race, you could hold the button for at least 4 and at most 11 and beat the record. Third race, you could hold the button for at least 11 or more than 19 and still beat the record. See how much margin of error you have. Determine the number of ways you can beat the record in each race. If you multiply these values together, you get 288. All right, let's get the puzzle input and set up the template. Oh, well, that's pretty short input. Looks like there's 4 races with varying distances. This doesn't seem to be. Okay, so I guess this is the usual case where part 1 is, can you parse the input? And then part 2 is, let's overcomplicate things. All right. Someday I'm going to fix all of this mess. I don't want to do it on stream, though, because I think it might be too boring to watch. Okay. Let's create that. Create that. Day 6. Like that. And now we have unsolved and unsolved. Very good. I'm going to commit my template. Git add source. Git commit -m 2023 day 6 template. This is a test input from Oh, from yesterday. Guess what's happening to yesterday? Boom. Okay. So the first thing we'll do is we'll just generate a list of race info. So let's call struct race info. Oops, I don't know why I did a space there. And for each race, we're going to have a time. Right, that's the format, is time and distance. Let's call it the record, right? Because that's the record of the distance. And then the input is just going to be races of vec of race info. I think that's the way I would like to build things. This is going to be a little weird. Let lines equals AOC lib read lines input 06.text. So what we can do is split on the colon, split on the white space, and just collect all the numbers and all the records, and then just shove them in here, right? I'm not going to really iterate over lines. Let times equals lines of 0 dot split once on colons, doesn't matter, right? And then we're going to say dot 1 dot split white space, and then we're going to map the val dot parse dot collect, and then after that we're going to say, oh no, not parse collect, parse unwrap. I was getting ahead of myself. Collect vec I64. There. And we do the same thing for records, which is lines of 1. That should be, right? If I could do this. We should see that once I get this to compile. No field 1 on split once. Oh, unwrap. It's kind of an ugly thing. Oh. There we go. So we have our times and our records. So we just say for tr in times iter zip records iter self, what did I call them? Races. Push race info, time and record. So let's call it that, time record. Right, and then we can just print out, let's debug that. I'll put this self races. What did I do wrong here? Consider dereferencing. Oh, okay. Done. All right, so we have 38, 241, 94, blah, 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 blah. Okay. So now that I got that parse, how am I going to solve this? For each race, we have time t, right? And we have record R. And we can hold down the button for any amount of time between 0 and t, inclusive, right? We can hold it down for 0, or we can hold it down for 7 in this example, or any time in between. So we have a button times of 0 to t. So the total movement time, I have to reason this out. Movement time, movement with an E or not, is going to be t minus the button time. Right, whatever the button time works out to be. And the distance it's going to go is going to be button time times t minus button time. Right? That's the distance. Right? Because this is how much time is left. And button time tells it how fast it's moving. Yeah, that makes sense. And we have to get dist needs to be greater than r. Right? So we could rewrite this as button time times t minus button time is greater than r. And then we can kind of rearrange things, right? This is a quadratic here, right? We could say minus button time squared plus t times button time minus r has to be greater than 0. Right? If we solve this equation, then we have an answer, right? And that'll give us our curve, essentially. And as long as we have a value greater than 0, so we can solve for 0 and then just, yeah. Let's try that and see what happens. For race in self races. And we have race time and we have race record. Oh, what was the quadrant? I'm trying to remember. Was it b squared minus 4ac or something like that? Yeah, there's quadratic formula. B plus or minus the square root of b squared minus 4ac over 2a. Okay. And in this case, oh, do square roots in Rust, we need to be in float. So let's convert everything to float. Let a is equal to, in this case, it's just -1. Let b is equal to, and in this case, it's t. And in this case, c is, oh, I should put a space there. C is minus record. Oh, t, I called it t. It's race time. Race record as F64. And now we can solve the low and high times. Println, I don't know which is which though. For race, right? Let's do that. And then we can say let first solution is equal to, so it's b. Let's say plus b times b minus 4 times a times c, squirt, and all of that. It's negative b, right? I see it there now. I almost missed that. All divided by 2a. That's a redundant parentheses, but I don't care. And then the other one is minus, right? The second root is going to be minus that. So let's print those out. First dot dot second, and see what those numbers look like. And actually what we should be doing is, oh, right. Yeah, Rust is a little stickler. It won't auto-promote integers. So we got to make sure we put dots after them. All right, so we got numbers. Let's use the test input. Actually, you know what we could do is we can push the test input at the beginning, and then we can see all the other ones. Oh, but the answer is we're trying to multiply everything together, right? Okay. So let's do this. Let lines equals vec bang. Come on, you can type. And then we'll just put in the test input. Copy, paste, to string. Right? Let's just do that. And that should give us the values here. We don't have it quite right, do we? Okay, so we're going to have to... I got the order correct, so the first root and the second root are in the correct order. That was a 50-50 shot on that. But we have to seal this one, right? And we have to floor this one. Right? 2 to 5, 4 to 11, and 10 to 20. 2, 3, 4 are 5. 4 to 11, yes. And then, oh, 11 to 19. Oh, right, because of the inequality. Because of the inequality. We have to be greater than 0. And here, 10, I bet you that's equal to 0. So we might have to fiddle around with things a little bit. If I do this as I64, right? That will switch it back to integers. And then I can actually compare to see if they're equal. Maybe I don't do it that way. Oops. Because if that's exactly equal to 0, then we need to bump it up. Maybe I can do that. I'm just nervous about comparing floats directly, right? If I say if I'm going back into this equation here. So let's do this one. First times t minus b minus first. Is equal to the record, which is race record as F64. Yeah, comparing them equal like that, that's then we want to add 1 to first. First plus equals 1 point. Right? And we do the same thing for second. If second times b minus second is equal to race record as F64, second minus equals 1 dot, right? And pull them in. Yeah, now we have 11 to 19, and it didn't affect these guys. I think for these numbers, I think we're going to be okay. And then to get our answers, it's just multiplying how many different ways. Okay, so we're just multiplying. Let's start off answers. 1, and then we can just say answers multiplied equals second minus first as I64 plus 1. And then we just throw that in here. Answer. Zalphorax, thank you for the follow. What do we get? We got 288. So that matches the 288 here. Let's try the real input. We get a number. Ah, that's the right answer. How about that? Exciting. All right, that wasn't too bad. Yeah, I wonder how other people, I mean, you can obviously brute force it just by zooming up, but you know how much I dislike brute force solutions, especially for day 1, because day 2s can be kind of messy. All right, let me comment out these lines, because I don't know if I'm going to want them later. And then just rerun that real quick. Oh, I have one more to comment out. Actually, that one we can just delete. We don't need it at all. That's just dumping out data. Okay, git status. Git commit -am 2023 day 6 part 1. Who's ready for part 2? Nice Law says, why is +1 needed when accumulating? That's a good question. The reason we want it, if we take a look at the example input, I'm just going to go back here and not continue to part 2 yet. We know that we can go 2, 3, 4, or 5 milliseconds. We can pick 2, 3, or 4, or 5 milliseconds, right? So our high is 5 and our low is 2. So that gives us 4 different values. If we just say high minus low, 5 minus 2 is 3. So it won't include one of the ends, whichever end you care about. Right? If we're subtracting 2 off of it, right, then it will only include 3, 4, and 5. So we got to add 1 to get that, the original number. All right. 06. Oh, this should be 2306. There we go. All right. Let's see what part 2 is. Continue to part 2. As the race is about to start, you realize the piece of paper with race times and record distances you got earlier actually just has very bad kerning. there's really only one race. Ignore the spaces between the numbers on each line. All right. So it's actually, the race is actually 71 seconds long. And it goes 940 meters. That makes a lot more sense. But this isn't like, I guess if you did a brute force, it would just take a little bit longer, but that's not, okay. All right. And we could do, let's do it the quote unquote correct way. We're going to extract all of this into its own function. And let's just put it here, and what should we call it? Get range. We only care about the distance, so we can say just get, oh, this is how long you should hold it down for. How many ways to win? Ways to win. Given a time of I-64 and a record of I-64, and it's going to return an I-64. Right? And that's all it's going to do. And so instead of race.time, it's just going to be time. Race.record is going to be record. Same with these guys, right? And then we're going to return second minus first plus 1. Right? And that makes this just a fold. Right? We can say race iter fold 1 race, and we can say act times get ways to win race. And let me move all of this stuff down because this is just capturing my thoughts. I'll just put it right here. Like this. King Adriel, thank you for the follow. I probably missed a close. There we go. Let's see if we come up with the same number here. 1083852. Nope, I broke it. What did I break? An argument of type I-64 is missing. Oh, right. I just passed in the, yeah, let's do that. Let's pass in the race. So I can put all those other things back. Race is going to be a race info. I-64 with that. And now I have to put these back. race dot. Self races. Right? Okay, so that's a quick fold. And then instead, now I'm thinking, okay, how we want to do this. D. Scott Bogg says, why not just make it a method? Yeah. That's a good idea. I could just call it, right? I can just say race that get ways to win. Let's do that. That's a good idea. I don't know why I didn't think of that. Probably because I'm in a hurry and I need to get done. Let's put this down here. Impl race info. and this becomes self, right? Fast by 3 says, can you go over why you use that quadratic logic? Yeah, so that's what I was doing at the beginning of the stream, or the beginning of the puzzle. I was trying to figure out how to calculate the distance based on a given time and a current record. We can hold the button down from 0 milliseconds all the way up to t milliseconds, which gives us a movement time. This should be equals here. A movement time of t minus the amount of time we hold down the button. So the distance we go is going to be button time times the movement time, right? And we're looking for distances that are greater than our current record. And so then I just wrote this down, right? So this is the inequality we're trying to solve for. But once you multiply this out, you get a quadratic equation. And I also moved r to the left-hand side just to make it a quadratic inequality. Does that help fast by? I hope so, because that's the best I got, unfortunately. All right. Yeah, so now we can just do this, and we can say interfold, blah, 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 and say race like that. Let's rename this. Wins. There, that way it fits on one line. Oh, I blew it up. Oh, this should all be self now, right? Yep, and this still works. Okay, so this is a refactor of part 1. Git commit -am refactor part 1 in anticipation of part 2, right? But part 2 is going to be super easy. The only thing is I'm not saving this information. I'm not storing that. So we could either get really wacky, or I could just put it up in here. Part 2 time and part 2 record. Part 2 data. Because I want to pass in the race info, right? And then here, what are we going to do? We're going to say lines of 0. We could do it. Let part 2 time is equal to lines of 0. Dot split once on the colon. Oh yeah, Clippy's going to complain about the single character strings there. Okay, split once 1 dot, and now we want to strip the white space, right? Everywhere. Filter ch is white space. I think I can do that. Collect it into a string. And then parse as an I64. Is that going to work? It says unknown. Oh, I need to define default for this. Okay. That's something I just do so I can create these things. Split once, unwrap. I forgot the unwrap before also. Seems to be a blind spot for me. Chars. All right, let me print that out. Oh, it's an OK. Unwrap. All right, hopefully that's right. Cat. Oh, I have it here, right? Where is it? Yeah. 389479770. Yes. Okay. Adar Chantal 007 says, I love your NeoVim configuration. Can you please share it? Yeah, if you do bang NVim in chat, it'll give you a link. This is basically Togglebit's NeoVim config. So I just stole his, and I tweaked it a little bit for me, but it's essentially just his. So part 2 record. Right? Let's just make sure we get that right. That's a very big number. 241, 1549, I see it there. 1074, I see it there. 1091, I see it there. Okay. And now all we have to do is print it out, right? Oh, we have to put it in our part 2. Self part 2 data equals race info time. Oh, you can't do completion there, huh? Part 2 time record part 2 record. All right, now we don't need these. And now part 2 just becomes self part 2 data. There we go. And then wins. We got a number. Hey, that's the right answer. How about that? Exciting. Yeah, part 2 is pretty easy. Once you did part 1. Git commit -am 2023 day 6 part 2 is done. And that's good that it was quick because I have to go. I can't keep going. I can't keep streaming. Get push.